Y'all ready for this? All right, we got a little split screen going. I'm going to get my face out of there. Not that you want to see it anyway, but it's just a lot going on this screen. We got the review on one side, we got Desmos on the other side. Let's just get going here. All right, number one. It's giving us a bunch of numbers. It wants us to find all this stuff: mean, median, Q1, Q3, minimum, maximum. Now, we're all good with the minimum and maximum. Very happy about that. So if you look at all these numbers on top, just the top numbers first, we're looking at all those numbers in purple. And we can bring up in Desmos, I put all those numbers here. These are the purple numbers under the X1. Now, if I want to find the 5 number summary, I can click the box below. I can hit functions. I can go down to where it says stats. And then I have to put in where the numbers are, what column. So they're in the X1 column. So I do have to hit X1 to give me all my stats. So here we go. These are the original grades that we're putting in. We have a minimum of 60, a maximum 82, and Q1 66, Q3 81. Sorry if it's a little sloppy there. I'll try and be neater. And a median of 79. Now the mean, how do we get the mean? Well, there is a way to get the mean in Desmos. Otherwise, we add up all these numbers, these purple numbers, and we divide by 8. That would give us the mean. But let me show you a way in Desmos that we can get it. So if you go to your Desmos and go to your scientific calculator, so you go to like the home page in Desmos, and instead of the graphing calculator, you use the scientific calculator. And you go to where it says function at the bottom here. It's on main, but you go to function. And then in function, I'm going to try and get rid of this here. How do I get rid of this? Okay, in function, you hit mean. Mean is right behind this thing that's blocking it. And then you put in all your numbers. So 60, comma, you got 72, comma, okay, we put in all those numbers, and there it is. 74.25 was the mean of the first one. We have 74.25. And then if we added the other two numbers in, we'll get the mean of that. The other two numbers that they want us to add in are 58 and 70. And our mean is 72.2. All right. Now we need the other median, Q1, Q3, all the other stuff from the data with the other two numbers put in. Now I went into here and notice this is X2 at the top. So when I do my stats, and I can just type in stats, okay, parentheses, X2, and it gives me my 5 number summary. So we're going to put those numbers in. And we have all our numbers. Okay, so what do these do? Does the mean increase, decrease, or stays the same? So the mean decreased, the median also decreased, our Q1 decreased, our Q3 decreased, our minimum decreased. Wow, all decreased, and our maximum stayed the same. All right, there you have it for number one. All right, number two. We have the following data, and we're trying to see if this box and whisker plot is correct. So let's put all the numbers in, which I did here. Okay, I like to count just to make sure I have the right amount of numbers in case I didn't miss one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. Okay. And notice this is x3 at the top. So we have x3 here. So we're going to do stats, parentheses, x3. And we have our minimum 1, which means that this right here should go right down to the number 1. And it does. That's the minimum. Our Q1 is 4. Yep, that looks like 4 right there. Our Q1 is 4. That looks pretty good right there. And let's see what the median is. The median's 12. No, they have the median at 9. That's middle line there is the median. Okay, so median should be 9. Let's check the others though. See if there's any other mistakes. This looks like it's 21 here. That's Q3. Yep. And then the maximum. Yeah, that looks like it's 25. So the only mistake that was made is the median. All right, the next one. We have the boys and the girls. The data below shows the number of hours boys and girls spent studying for a test. We're going to look at the IQR for the boys. Well, first of all, you have to know how to get IQR. Do you know how to get IQR, the interquartile range? IQR is Q3 minus Q1. That's how you get your IQR. So we're going to do our 5-number summary here. And we're going to do, what was that? What? Was that X4 on this one? Let's go up a little higher. X4 on this one. Let's do stats, parentheses, X4. And here's our 5-number summary. So the IQR is going to be Q3, which is 2 for the boys here. Q2 minus Q1, which is equal to 1. Now let's get the girls' IQR. This is going to be X5 here. Stats, parentheses, X5. Q3 is 4. Q1 is 2. So we're going to do 4 minus 2, and that equals 2. The sum, what does sum mean in math? You know it. Sum means you're going to add those two numbers. 1 plus 2 equals 3. All right. Number 4. When an outlier is added to a set of symmetric data, which measure of center will most likely change the most? All right. So which one is going to change the most? This is a good question. The range could change the most. The mean can change a lot too. The median's not going to change a lot. Let's just say, for example, let's get a bunch of data, all right? We're going to get 7, 9, 11, 14, 12, 8, 6, 5. All right, we have all that data. And just to guess, the mean would be around somewhere in the middle between there if you average them all. The mean would be around 9. But if we throw a number like 30 in there, it's going to make the mean increase more than what it should because we have this outlier here. Now the range, well, the range is the big number minus the small number. I think the range is actually what's going to change the most when you have an outlier there, because this big number 30 minus the small number 5, the range would be 25 there. And I think that's going to increase much more than the mean will. All right, we're going next. We're going to match this histogram to the data. Now we have to kind of look and see where the data falls. So when we do this, it says 0, 10, 20, 30. But the first one is 0 through 9. Then we have 10 through 19. Then we have 20 through 29. Then we have 30 through 39. And we have 40 through 49. Okay, so that's important. It's 0 through 9 is the first one. So how many are 0 through 9? 1, 2, 3. 3 are 0 through 9. So that should go up to the number 3. So let's look at all of these. The first one goes up to 3. So 10 through 19, we have, I'll get a different color here. We have 1, 2, 3. 3 more. So that should be 3 also. So I know C is not going to be right. C is not right because this column goes up to 5 and we only have 3. Okay. And E is not going to be right because that goes up to 5 also, that second column. So it has to be B. Why does it say BEC instead of ABC? I don't know. That's just the way it is. But just as a check, let me do a couple more. 20 through 29. It's not taking me that long. It's going to be 1, 2, 3, 4. 1, 2, 3, 4. And that goes up to 4. And then the next one, just one more, 30 through 39. We have 36. That's it, just one. And that's it, just one here. Just one here. That goes down to 1. All right. Hopefully that made sense. Number 6. All right. What do they want to know in number 6? Describe the shape and best measure of center. Well, this looks like it's symmetric. And the best measure of center for symmetric is going to be the mean. Okay, because we have no outliers. And if you say no, you're being mean. Here is skewed which way? Some people get confused. It's skewed to the right. Let's make a dinosaur and then make his tail. The tail is going to be to the right. Very fierce looking dinosaur there. Skewed right. And that means you have an outlier. The answer is yes. So you're going to get a medium coffee. Median. Okay, when you say yes, you get a free medium coffee from Dunkin' Donuts, and that's a median. This one, we have a dinosaur again, and we have the tail now to the left. So this is skewed left, and again, we are going to use the median, okay, because we have an outlier. The mean will mess up, the outlier will mess up the mean. All right, next one. All right. Total daily sales of 2 different stores are given. All right, so we have store 1 and store 2. So I think I have this standard deviation here somewhere. All right, here we go. So we're looking for the standard deviation. I put in for x1 and y1. So we're going to go to functions here. We're going to go to stats, and we're going to do standard deviation p, and we're going to put in x1, and that's going to be 100.52 for 1. It says round to their hundredths. So I'll just do 100.53. 100 has 2 zeros. So we know we need 2 numbers after the decimal in our answer to round to the nearest hundredth. Now the standard deviation for store 2, I'm going to change this x1 to a y1 because that's the second column. 133, I'm going to round to 0.21. And which store has the greatest? It's going to be store 2. And by how much? Well, you guys can do that. You guys can subtract. Do 133.21 minus 100.53, and you get the answer, and you will round to the nearest hundredth on that one. All right. Number 8, little difficult to see. So the largest interquartile range. So the IQR, do you remember how to get IQR? It's Q3 minus Q1. So which one is the largest? So we have to do all 3 to see which one's the largest. Q3 is right here, this end box. Q1 is this first box over here. Okay, so you're going to do Q3, I think that's 80 minus, that looks like 25, and that's going to be 65. For the next one, it's the last box. It looks like 80 again, minus, looks like 55, and that's going to be 25. And the last one, it looks like it's going to be 50 minus, let's say 35, and that's going to be 15. All right, so the largest interquartile range was A, and the smallest interquartile range was C. And you can kind of tell how far these boxes are. They're a lot further apart than these boxes here. And these boxes are the closest over there. All right, let's look at number 9. We have all this data here, and then we're going to add an outlier. So let's do this in Desmos here. All right, We're going to start a new Desmos to enter our data. We hit the plus button and we get to the table here. And we're going to do 2, 5, 12. All right. So we have our data here, and it's asking about the mean and the median here. So actually, it's better to put it in the other Desmos that we had before, the one that shows the mean here. And let me get that one going. All right, and that one's going to give us 11 as our mean, excuse me. So the mean will be 11. So let's remember that the original one, the mean is 11. And now if we add 40 to it, let's add or 42 to it, the mean is going to go up to 13.38. So the mean will increase here. The mean will increase. All right, that was easy enough. Number 10, if 20 is removed from this data set, which statement will be true? All right, should we test it out? All right, let's see what happens with this. So we'll go 50. All right, so with 20 in, we have a mean of 50.33. And then if we take the 20 out, we have a mean of 56.4. So if we take it out, if we remove it, the mean will increase. The mean is going to increase. Now, A doesn't even make sense at all. 20 won't be in there. The mode is not going to change because the mode is the most often. That's 55. And this, the mean will increase. All right. Which box plot has the greater IQR? Well, before even doing it, I can tell this one will because it's the widest from Q3 to Q1. Okay, so it's got to have the greatest IQR if it's the widest. So that's going to be B. Which has the greater median? Ooh, the median is right here and right here. Same. It's not A or B. The greater range. That's the biggest number minus the smallest. Okay, that's the maximum right here minus the minimum right here. Okay, so which one is going to be the greatest? Well, A is going to be 100 minus 50, and B is going to be 100 minus 40. So that's going to be B, the greater range. The greater Q1, this is Q1 right here, Q1, that's going to be A. And the greater Q3 is the last box before it goes out to a whisker. This is Q3 here. This is Q3 here. Which is greater? That's going to be B. All right, number 12. We're moving here. Box plots show, and they want to know in which box plot do 50% of the students score above 50? Woof. All right. So let's remember this is 25, this is 25%, this is 25%, this is 25%. 50 is right here. Okay. So if we add up these two 25s on the right, let me give a little highlight. Okay. These two. If we add up these two, these are the two that are right after 50. That's going to total 50. 25 plus 25. So that's going to be A. Which box plots do 25% of the students score below 23? So we're looking for a 23 that's going to be right here, 25%. So let me get a little highlight. All right here is below 23. 23 is below here. That's only a part of that line. So that's not 25%. 23 is starting over here. Okay, so it's got to be A again. A little tricky, both giving A's. I like it though. Throw a little trick in there every once in a while. We're okay with that. All right. 13. All right. Johnny scored the following on his tests. All right. He got these scores. His teacher let him retake the test, and the low score, that 50, the 55, was thrown out and it was replaced with a 68. So, what do you think is going to happen to the mean? It's going to increase. What do you think is going to happen with the median? Well, let's see. Let's test it out. We have 55, 70, 82, 90, 100. The median is 82. Well, let's throw out the 55 and replace it with a 68. The median is still 82. Stays the same. 14. Distribution for test scores for 25 students in math class have a median of 70%. Okay. Median of 70%. That means 50% got above 70 and 50% got below 70. And a standard deviation of 9.1. One of the students does test corrections and increases his score from 85 to 95. What will this do to the mean? Well, it would increase the mean, and the standard deviation. Let's check out what it would do to the standard deviation. All right, let's throw in these numbers and let's just give it a check. All right, let's get some fresh Desmos numbers to put in. All right. Oh, we don't have all these numbers. We're just asking what it will do. Okay. So the standard deviation is going to be 9.1. So if you go from an 85 to a 95, okay, that standard deviation is going to increase, okay, because the mean was a 70. All right. So if you're going further away, that 95 is further away from the median of 70. So if it's going further, we went from 85 to 95. It's further away from the median, so the standard deviation is going to increase. All right. Number 15. We got number 15. Baseball team runs per inning. They scored 0 runs 4 times. So that means 0 times 4, or actually 0, 0, 0, 0 is what we have to do there. They scored 1 run 3 times. Okay, 1, 1, 1. They scored 2 runs 1 time and 3 runs 1 time. So they want to know the mean number of runs. We're going to add up all these. 1, 2, 3, that's 0. 1, that's 2, 3, 4, 5, 6, 7, 8. That's 8 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. 8 divided by 9. Let me just make sure that's right. 4, 5, 6, 7, 8, 9. Yep. And we got 3, 4, 5, 6, 7, 8. Whatever 8 divided by 9, that is going to be your answer. 16. A set of data. The lower quartile is 26, the median is 40, and the upper is 62. Which value would be an outlier using the 1.5 IQR criteria? Well, let's check out what the 1.5 IQR would be. Well, let's find out what the IQR will be. Remember how to get IQR? It's Q3 minus Q1. So the upper quartile is 62. The lower quartile, that's Q3, by the way, is the upper. Q1 is the lower. So we do 62 minus 26. Let's go into the calculator here. 62 minus 26. We got 36, okay? This is the IQR. Now we have to take that 36 and we have to multiply it by 1.5. And that's going to be 54. So what we do now is we take the upper quartile and we add 54 to it, 62 plus 54. And that's going to be 116. So the upper outlier is 116. And the lower outlier is going to be 26. Notice we used 62 before, okay? 62 every time because that's Q3. Then we take Q1, we take 26, and we subtract 54. That's our IQR times 1.5. That equaled 54. So 26 minus 54 gives us negative 28. That's the lower outlier. All right, let's see if we can get through this page. 17, 18, 19, 20. I'm not sure. Running out of steam here a little bit. All right. Johnny recorded his bowling scores for 8 games, and there they are. He played another game but had a broken finger. Yeah, excuses. And scored a 45. What happens to his data? Well, it's definitely going to be more skewed to the left because that 45 is going to be all the way down here, and all the other numbers are going to be to the right. It's not going to be more skewed to the right. It's not going to be unchanged, and we definitely have enough information. Definitely going to be A. All right. Make sure you're pausing this and doing this on your own, then checking your answers. Box plots. All right. True or false? Group A has a bigger spread. Spread is maximum minus minimum. Group A does not have a Group A does have a bigger spread. Okay? Bigger spread. See, it's longer from one end to the other. This is a true statement. Group B has a bigger IQR. Well, that's going to be IQR. Remember, Q3 minus Q1. Well, this is kind of tight. I would say that's about 58 minus 32. Let's see what that is. I'm looking at the bottom one first. 58 minus 32. That's going to be about 26, the IQR for B. And A is, well, what's that about? 55 minus 30. Let's see. 55 minus 30. I'd say that's 25. Oof. That is close, almost too close to call. Group B has a bigger. I would say that's true. Okay. It's very close, though. Too close. The median of Group A is higher. Well, that's for sure. This is the median. That line in the middle of the boxes. True statement. Group B had the person that shopped the longest. Okay, this is shopping the longest. That is true. That is the person that shopped the longest. That is true. All right, I don't love that we had all trues. Throwing me off a little bit. I always like to see some true falses when you have 4 different questions. But you know that B is it's a little tight. I'll be honest with you, a little tight on the B on the second answer there. All right, 19. Given this data, we have a high outlier and low outlier. All right. So let me slow down here a bit. All right. We got to find Q3 and Q1 to find the IQR first. So I'm going to put the data in 25. I have 1, 2, 3, 4, 5, 6, 7 numbers there. 1, 2, 3, 4, 5, 6, 7 numbers there. All right. I got them all. We're going to do stats, parentheses, X1. We have our 5 number summary. We need our IQR, and that's going to be Q3. Remember IQR, Q3 minus Q1. And the IQR of Q3 is, or the Q3 is 32 minus 26. So our IQR equals 6. Now we have to take that number and multiply it with 1.5. This is to get, well, let's just do that first, and I'll explain why we do it. 6 times 1.5. I think that's going to be 9. Okay, it equals 9. Now we take that 9 that we did, the 6 times 1.5. We did the IQR times 1.5, and now we take the Q3 and we add 9 to it. That's going to be 32. Our Q3 on the right here was 32, and we see that over here. Okay, 32 plus 9. That's going to be the high outlier. It has to be greater than 32 plus 9 is 41. Now, the other outlier is taking 26 and subtracting 9, and that's going to be 17. 26 minus 9. Is there a number below 17? I don't see one. Is there a number above 41? I don't see one. There are no outliers here. All right. 20. Which curve has the greater standard deviation? The greater standard deviation is going to be the wider mound. The wider mound is going to be the greater standard deviation. Okay, the scores are more spread out, so it is going to be B. All right, going to take a little break before we do the last page there. Hope I didn't go too fast. I'll see you soon.